So this is another one of my series of talks on and trying to improve software practices in the SDR community. Based on what I've seen with trying to get people to use upstream kernels, I'm not doing so well. No. So let's try again and try to get your, to motivate you to do more on-target testing of your embedded systems. So at this point, GNU Radio runs on lots of different processors. And the current matrix is 32 and 64-bit processors and ARM and Intel ISAs. So that's sort of the basic matrix. So one of the things with QA is your underlying distro packages can also impact your QA. Something that we ran across in the past couple of years with an OpenEmbedded build is an older OpenEmbedded build called Zeus introduced GCC9, and GCC9 would miscompile an FFTW function. So if you've got something based on Zeus with GNU Radio, your grFFT block doesn't work. Not too many people noticed it, but just enough people noticed it's a pain in the butt. So this sort of motivated me to get more exhaustive testing of embedded builds. The QA tests in GNU Radio are designed to be run on your build machine. So you type make, you wait a while, and then you type make test, and it runs the QA. And it has to go through a number of hoops to run the QA tests on your build machine. And I think those are going to be talked about in the next slide. But if you're doing a cross-compile, you build for a different architecture, so the binaries just won't run. Okay, so I do my builds using OpenEmbedded, so I'm building a complete Linux distribution in one go. So I have pretty fine control over the packages and versions I'm using. The default OpenEmbedded build supports no hardware or no real hardware, but it supports several QEMU machines. Funnily enough, the 32, 64-bit ARM and Intel, and some other ones that we really don't care about, except for the guy who once had me do some PowerPC 64 work. And as a side, just because it's a big buzzword these days, they're adding support to do software bill of materials so that you actually have something that you can show people, you know, what your software is composed of. And I just put that in there because it's become a big buzzword, as we saw this morning. OpenEmbedded has a key principle is keep your, what I'll call your application code separate from your machine and your distribution definition. So for the purpose of this, we'll call applications the user space code, basically your root file system. The machine code is the kernel and other software packages required to support your specific hardware. And distribution is basically a small set of policies and very specific stuff like, do I support X or not? You know, do I have displays, things like that. It will fetch all your source, compile it, create packages in various formats, and then assemble images from these packages that you've created. Okay, so package QA testing. So typically, like I was alluding to, is you typically run make test, and then you get all your results. If you're cross-compiling, this doesn't work. Okay, so care is taken with your newly built libraries. When you're running the QA code on your build machine, you clearly don't want to be using libraries that you just built. They're installed in the machine. So there are a lot of wrapper functions in place to change the library path so that you use the newly built libraries. And you'll see a lot of this in the GNU Radio QA code. So the workaround is OpenEmbedded supports a concept of taking test code and packaging it. And taking the test code and packaging it tends to be a pretty manual process. You have to understand the structure of the test code figure out all the wrappers and usually just remove the wrappers because you're going to be running the libraries that you're going to be testing on the image that you're going to be testing with. Okay, so this is a piece of an OpenEmbedded recipe where I'm assembling the test code. And if you've looked at the GNU Radio test code, you'll see what I'm doing is I'm basically copying files QA*sh. So that's all the shell files that run the GNU Radio QA into basically a deployment path that I'll package them out of. I also pick up the ctestfiles.cmake files, which are important for running the tests. And I also have to pick up the Python files. So you can sort of see, and I'm taking some of that out of the build area and some of that out of the source area. So it's definitely a lot of gymnastics to extract QA code from a source tree. And then I'm missing some ctest files because they don't have regular file names yet, and that is some future work. On the other hand, to run the test code, once I've actually installed it in a known location on the image, I can basically have a file called run ptest that basically calls ctest with this ctest file cmake that will recursively descend a directory tree. So running it on the target is actually fairly easy, and it gives me the nice normal output that you expect to see. So I'm using Buildbot to automate my builds. So I'll build a ptest image, and then OpenEmbedded gives me a script file that I use to start QEMU. And my Buildbot then has a script that it runs that SSHs into the QEMU that's running. And that's a little bit shaky, but I'm guessing the IP number and it's pretty stable most of the time. I run the tests, I collect them into a text file. And so the problem is once you have the tests, how are you going to inspect them? So what I do is I commit them into I commit the result file into a Git repository. And then I can look at the diffs to see what changes from run to run. Because really what I'm looking at are changes. You know, if there are no changes, then I get a very small diff with only a little bit of noise. Now I did have to post-process the diff. I'm running the QA for FFTW, and it was very noisy. So I had to basically eliminate most of the lines that it reported because they're basically just random noise for some reason, and find the pass-fail lines. The GNU Radio test code likes to record how long it took the test to run. And invariably those differ slightly. So I had to edit out the times. So if you look at the result file in the Git repository that I have a URL to in the last slide, you'll see that the results look a little bit different than what you would expect. And this is sort of the common thing I see as a diff if I haven't, made any serious changes to the code. The QA rotator QA code, I believe they alluded to this in the maintainer talk. Some of the QA in GNU Radio is not stable. So it will like randomly or semi-randomly alternate between passing and failing. So this is just a really good illustration of what I'll see in a typical commit from a GNU Radio run. So I've got the interesting part of this talk are basically go look at the last URL. It's spelled GNU Radio because I was just putting this together really quickly. I mistyped the URL when I created the Git repository, and I'm too lazy to fix it. So at some point, I'm going to break that URL and fix it. But for now, it's there. It's collecting results for master builds, or the Octo project master builds, which is testing GNU Radio Master. And I've got a branch set up that's tracking the Hardknot release, which is somewhat more stable, and it is tracking GNU Radio 3.9 builds. And with that, I'll let the next speaker have the rest of the time.